Hi, this is Jason Rowe. Today we'll be discussing the cardiac output and the autonomic nervous system's influence on that. The cardiovascular system is a self-contained system, a closed system that connects the heart, which acts like a pump in the system, to blood vessels of the body. The heart pumps blood through these blood vessels to provide oxygen and nutrients to the body. The heart has four chambers: right atrium, right ventricle, left atrium, left ventricle. Start with the right atrium. This is where you receive blood from the body. That's mostly oxygen poor. Then moves to the right ventricle, and the blood is pumped from there through the pulmonary arteries to the lungs, and then the lungs, the blood becomes oxygenated and returns to the left atrium through this pulmonary set of veins, and from there, this now oxygenated blood moves from the left ventricle, is pumped back out into the body, into our tissues. So to perform this function, a heart has to beat at regular intervals all throughout our life, all day, every day, 24/7. And there are specialized cardiac cells that control the heart's electrical impulses that make this happen in a well-coordinated system of activity. And this is known as the intrinsic conduction system. Starts with a discharge at the sinoatrial node, which is a nerve bundle at the atria. This causes a atrial depolarization and a contraction of that chamber of the heart. This entire pathway of electrical activity through the heart is made up of this sinoatrial node, ventral atrial node, bundle of His, and the Purkinje fibers. The electrical signals that activate heart activity, they're all in sync and happen together, which is awesome. But despite the system being able to spontaneously depolarize, it needs to be able to respond to varying needs of the body. We have continuously changing needs for our body tissues that require the heart rate and cardiovascular system to have varying output. Heart rate and functions are regulated by the autonomic nervous system, as well as hormones to make the adjustments needed. So this autonomic nervous system, often abbreviated ANS, is part of the peripheral nervous system that oversees contractions of the cardiac muscles, as well as function of glands and different activities in the body. Its main role is to regulate the body function, including the heart rate and our blood pressure, respiration rates, body temperature, sweating, movement in our gastrointestinal tract. These functions are really important for maintaining an internal balance, homeostasis of the body. So it helps balance our body. And the autonomic nervous system, it does this automatically. We operate it subconsciously. We don't have to put any thought into making it happen throughout our day. Being controlled by nerve centers in the spinal cord and the brain stem. So here, the autonomic system is interconnection of two systems. We've got the parasympathetic system and the sympathetic system here. These systems have contrasting effects on the heart. The sympathetic system prepares the body for situations that need a lot of energy for flight or fight or flight response, they call it. Then on the other hand, the parasympathetic system is most active when we're at rest. It can counteract the sympathetic system. So after a stressful event, or if we're using a lot of energy, it helps return our body to like a relaxing state. And the sympathetic system releases neuroepinephrine, and the parasympathetic system releases acetylcholine. The sympathetic stimulation stimulation by the sympathetic system increases the heart rate and the strength of muscle contractions, like during exercise. If we get excited, either physically or emotionally, and then sometimes under certain health conditions like heart failure, the system can become activated. It also affects other bodily functions, pupil dilation, bronchial dilation, blood vessel constriction, how we sweat. It can inhibit digestion, increase renin secretion by the kidneys. It can induce contractions in the reproductive organs. And then on the other end of the spectrum, you've got the parasympathetic system, which its stimulation decreases heart rate, constricts the pupils, promotes digestion instead of slowing it down, enhances salivary output, and can constrict the bronchioles. Most organs are connected by have a connection by both of these systems. There are some exceptions, however. So the parasympathetic system is mostly connected by the midbrain here, where the brainstem and medulla oblongata are is what connects the parasympathetic system, and where the sympathetic system is connected by these sacral nerves here at the top of the spinal cord. In the sympathetic system, the nerves originate at this, sorry, I said it wrong, the thoracolumnar area right here of the spinal cord, and extend outward to the targeted organs. In this case, we're focusing on the heart, obviously. But there are some fibers that can originate from sacral regions. These nerves have a short preganglionic neuron followed by a relatively long postganglionic neuron. The parasympathetic nerves, like the vagus nerve, which makes up 75% of the parasympathetic fibers, has a much longer preganglionic neuron and a shorter postganglionic neuron as well. So here at table 1, we can see the receptors at the ends of these nerves and their functions in both a sympathetic and parasympathetic system, which are denoted here by the different neurotransmitters that they put out. So both the sympathetic and postsympathetic systems neurons can release acetylcholine, which is classified as a cholinergic. The majority of postganglionic endings of the sympathetic nervous system release norepinephrine, which is similar to epinephrine, by the way. As a result, these postganglionic fibers of the sympathetic system are commonly referred to as adrenergic fibers. There's 2 types of adrenergic receptors, this alpha and beta, and we have the alpha 1 and beta 1 and 2 listed here. And the graphic is a breakdown of how they work. Alpha 1 causes vasoconstriction, as does the beta 1, is written over here with the function. They increase the heart rate and cause vasodilation as well, increasing blood perfusions through the targeted organs like the heart. The overall effect these receptors can have on the heart, they refer to as inotropy, chronotropy, and domotropy here. And in that same order, it means the increase in heart contractions, the increase of heart rate, and the enhancement of conductivity of the electrical system. And then, as we mentioned earlier, the parasympathetic nervous system is responsible for these involuntary regulations of various bodily systems like salivation, tear production, digestion. It plays an opposing role in the heart function. And in this case, we're looking here, the parasympathetic system consists of this preganglionic neuron coming from the neurons in the midbrain and pons and medulla oblongata, as I mentioned, mostly the vagus nerve. It's an important role in regulating the heart as well as the lungs and stomach and other visceral organs. It produces acetylcholine, which is the main neurotransmitter used by the parasympathetic system. It's the same one as used as in skeletal muscles, but in the heart muscle, it has an opposite effect. It inhibits contraction by activating these M2 receptors, as we have listed here under our receptors. These postganglionic fibers of the parasympathetic system are referred to as cholinergic fibers because they release acetylcholine as the nerve endings. And it's acetylcholine binds to these M2 receptors and has the effect of decreasing heart rate until it reaches like a regular rhythm, a resting heartbeat, so to say. It does this by slowing down depolarization rates and reducing the conduction speed through the atrioventricular node. Also, the activation of M2 receptors decreases contractibility of the atrium, and this also helps bring everything to a slower setting. So apart from the autonomic nervous system, various endocrine hormones also impact cardiovascular function. Epinephrine, dopamine, which both convert to norepinephrine, are substances released by the adrenal glands that play a role in triggering this fight or flight response that we start with in our explanation. On the other hand, hormones such as vasopressin, renin, aldosterone, and the natriuretic peptide, ANP, contribute to water reabsorptions. Obviously, because of this, some of these are found in the kidneys where water retention reabsorption can happen. And this is the whole aim of this is to regulate blood pressure. The heart itself produces two important hormones that affect blood pressure and heart function. First one is this natriuretic peptide ANP, which is released by cells in the atria of the heart. ANP helps lower blood pressure by various mechanisms. It's produced and stored in atrial cells and in other organs. When it's released, it blocks the effects catecholamines in the blood vessels and inhibits heart muscle growth that can be caused by norepinephrine. It's also believed to protect the heart by preventing cardiac fibrosis, which is after damage caused by lack of blood flow to different areas. The second hormone produced is this brain natriuretic peptide BNP, which is produced by cells in the ventricles. It's similar to ANP. It's released when the ventricle cells are excessively stretched out. The level of BNP in the blood is often increased in patients where the left ventricle has a malfunction or a dysfunction, and it's used clinically to monitor heart function. So if they see high levels of BNP, it's usually a sign of a poor function of the left ventricle, so possibly a heart failure. So in summary, the heart is not an isolated entity. It's part of a larger cardiovascular system that responds to both immediate and long-term changes in blood pressure and balance of the body. The primary function of the cardiovascular systems are to maintain a balance and ensure our survival. The system is influenced by various factors ranging from the central nervous system, that's including the brain and spinal cord, of the peripheral nervous system, which extends through the spinal nerves to glands like the adrenal gland, blood vessels, even the urinary system, specifically the kidneys for water reabsorption. Controlling the cardiovascular system involves not only its intrinsic conduction system, but also significant influences of the autonomic nervous system and the endocrine system as well. Thank you for watching.